Hello, hello, good afternoon. Welcome everyone to the MIT Museum. We're absolutely delighted to have you all here for a very special day. I'm John Oxendorf, Director of the Morningside Academy for Design at MIT. We are a new entity. We are MAD, and MAD is elevating design across all of MIT. I'm joined by a number of my MAD colleagues who you can imagine are a lot of fun to work with. Thank you, Adelaide, Professor Maria Yang, Marion Cunningham, Roy Salguero Barrio, and I'm sure I'm missing others, Jen Spungen. So on behalf of the whole MAD team, welcome one and all. This is our third year announcing the new graduate fellowships in design at MIT. Every year we name MAD fellows from across all of MIT and we support their graduate studies. Before we launch into tonight's program, I'd also like to advertise and invite you all back to the museum at 4 o'clock tomorrow for a program MAD is helping to organize together with the museum and with Innovators for Purpose. And that is in a Design Redefined series. And the program tomorrow is on shaping shared spaces and on open space. And so that should be a great program in the same place tomorrow at 4 o'clock. Please join us. So tonight, or this afternoon, we're all about the new cohort of design fellows. We're going to introduce them briefly, but because this is our third cohort now in only 2 years, that brings us to 34 total graduate students across all of MIT who we've been supporting. We're going to bring 3 generations of design fellows together to explore how they think about design, how their work cuts across time, space, and fields. And this is all part of a very strong and vibrant design community at MIT. And one of the main goals of MAD is to bring these communities together and strengthen them. And obviously, we have a very strong social mission to frankly improve the world through design. So tonight, our discussions will be around 3 themes: the themes of bodies, objects, and environments. And we'll have time for audience Q&A at the end of each of the 3 panels. You might think this would be a 3-hour program, but we're going to try to keep it punchy and short in about an hour and a half. So hopefully it'll be exciting and interesting for you as well. And there'll be a little bit of time afterwards to meet some of these extraordinary designers. I would like to begin with a land acknowledgement that MAD acknowledges Indigenous peoples as the traditional stewards of the land and the enduring relationship that exists between them and their traditional territories. The land on which we sit is the home of the Massachusetts, the Pequot, Shawmut, and the Mashawamak. In the 19th century, the traumatized remnants, refugees, and survivors of these groups and others formed the Wampanoag to consolidate their position and become the inheritors of the land. We acknowledge this painful history of genocide and forced occupation of their territory, and we honor and respect the many diverse Indigenous people connected to this land on which we gather. So at this point, without further ado, we would like to announce 10 new graduate design fellows from across all corners of MIT, and we will do that with a brief video, and then we'll invite them up onto the stage.
I kind of think of design generally as problem solving.
I like to say that design is a journey, a exploración colectiva.
It's about iterating, trying again, getting feedback, and updating.
Design is a creative toolset to advocate for justice and equity.
Design is not just beauty and aesthetics. I think when I tell my friends I'm a designer, they think I just design beautiful stuff. And of course I design beautiful stuff, but they're also practical, functional, and optimized.
Design is not exclusive or exclusionary. I don't think you have to be a professional designer to design. I think it's really just about taking action.
What do you research? I use my design frameworks to create soft robots that can gently interact with the world or work in uncertain environments.
Designing structures to minimize the embodied carbon based on where you're located in the world and what materials you have access to.
self-directed therapy chatbot for postpartum depression.
I'm developing tools and workflows to enhance collaboration between humans, machines, and materials.
We aim to help people that live in informal settlements to access to the digital world and also to secure their livelihoods.
I teach AI to design.
How disasters and their effects accumulate for marginalized communities and what that means in policy and urban design.
Discover and construct different types of structures that can achieve extreme properties.
How to depart from the current construction industry, from growing buildings with biomaterials to deploy advanced 3D printing technologies.
The way that we can design tools and systems using what we know about sensory systems and the body to improve our social connections and our learning.
Do you have a design hero? Jane Jacobs was a journalist. She established that cities and society should be focused on the human and not like in big infrastructures. I see her as like my role model. I love her.
Alberto López Gómez and every other Mexican artisan.
Minimalist or maximalist?
Definitely minimalist.
I think I live as a minimalist and I design as a maximalist.
I think I've been a lifelong minimalist that's slowly easing toward the dark side of maximalism.
What are your design superpowers? I have a background in painting and sculpture, and I think being able to combine this kind of creative thinking with algorithm and computer science is hopefully a little bit of a superpower for design.
To try and fail as quick as I can.
What is the biggest thing you've designed?
A malaria case detection project when I was doing the Peace Corps in Benin, West Africa.
The greenhouse in Nepal, we built it after one of the earthquakes.
The biggest thing I've designed is not in size but in meaning, and it's a storefront for an indigenous domestic worker to help her recover from a disaster.
A 36-foot tall timber tower where we repurposed discarded tree logs into a materially efficient timber structure.
I'm from Argentina and I've been designing my life in order to be here for a long time since I was a kid.
What is the smallest thing you've designed? Right now I'm using machine learning to design different types of metamaterials, and a few of the ones that we 3D printed, they're about the size of a piece of dust.
The box that I used to put the ring that I used to propose to my wife.
What do you hope to achieve with this fellowship?
To form new collaborations and relationships and expand my network within the design community.
A broader understanding of how to tackle some of the world's biggest and most important design problems.
Interviewing pregnant women and clinicians to better understand their needs and test our prototype.
Basically create the most generalizable design tool possible and affect as many designers and practitioners as possible with that.
What inspires you right now? Right now, I'm really inspired by the mountains and by structures that exist in nature. I think it's fascinating how the world around us evolves to optimal solutions that work really well despite uncertainty.
Generative AI and how that could really change the way we interface with making objects and designing things in our physical environment.
Favorite design tool?
I'd probably have to say pencil.
Paper.
Figma.
I would like to say maybe my hands, but I'd have to go with a 3D printer. I love 3D printers. They're my babies. Oh, that's terrible.
What are you excited about when you think of the fellowship?
Oh, I'm excited to see what everyone else is doing.
To be surrounded by people who can do things I cannot. That's when I'm the best version of myself. I think that's the community I'll find here.
And because of the generosity of the Morningside Foundation, the charitable arm of the T.H. Chan family, these fellowships at MIT are endowed for perpetuity. So every single year we'll be able to create and we'll support fellows in design from across the whole institute. So please join me in congratulating, and let's have the new cohort come on up. So I just have to say a couple of words to embarrass all of them while they're here in front of you. The video did an amazing job of introducing them, and I want to especially thank Adelaide and Connor and her team for pulling that together. I thought it was really terrific. So we'll just briefly introduce them, and please raise your hand when your name is called. So we have Sofia Chapero, who's a Master of City Planning and Urban Studies and Planning, and also participates in MIT Design X, our entrepreneurship incubator. Sophia. We have an MBA from the Sloan School, Clemence Couteau. Clemence? And a Master of Architecture candidate in the Department of Architecture, Mateo Fernandez. A PhD candidate in mechanical engineering, Charlotte Folinas. And Alex, that's exceptional timing. Come on, join everyone else. Alex Kyo. Welcome, Alex. Alex is an MArch in architecture and also doing a Master of Science in electrical engineering and computer science, because one master's was not hard enough, I guess. Dení López from Urban Studies and Planning is a PhD candidate. And a PhD candidate from Media Arts and Sciences at the Media Lab, Caitlin Morris. PhD candidate in electrical engineering and computer science, Maxine Peroni-Scharf. And a PhD candidate from mechanical engineering, Lyle Regenwetter. And finally, from civil and environmental engineering, a PhD candidate, Zane Schimmer. So at this point, I just have to say, it was incredibly difficult to choose these 10 fellows. We had 90 applicants from across all of MIT. We had a faculty committee who selected them. And we're absolutely delighted to get to spend the next year learning from all of you while we help support your work. So we hope it's a great year for all of you. And please join me in congratulating all of them once again. Okay, and now we're going to go to our program where we will have 3 short conversations between 3 cohorts of fellows. And we'll have one MAD fellow from each of the last 2 years together with the new fellow for this year. And so for our first grouping, we'll be talking about and exploring how design emerges out of the close attention to how individuals behave and interact at the scale of the body. And we will begin by inviting our new, and this panel will be made up of 3 fellows: Clemence Couteau, a new fellow, Alexandra Rieger, a fellow this current year, and then Mariama N'Diaye, a fellow from our first year in 2022. And so without further ado, we'd like to invite you up, and I think we'll present in that order. So over to you.
All right, I'm thrown into the deep end immediately. Hi, everyone. Thank you so much. My name is Clemence Couteau. I'm a first-year MBA student at MIT Sloan School of Management. And I am really excited to be a 2024 Design Fellow. I'll just spend the next few minutes talking a little bit about my project for this coming year, which will be designing a digital solution to prevent postpartum depression. So I've worked in the healthcare industry for the last 7 years. And one of the central questions in my work has been, how can I design simple, accessible, and effective tools to change people's health behaviors, especially in low resource settings? I started my career as a Peace Corps volunteer in Benin, West Africa. And there I built health education programs, especially around maternal and child health. This is an image of the health center I worked at for 2 years with women lining up to wait for their babies to be vaccinated. And when I came back to the US, I became really interested in how digital tools can be leveraged for healthcare delivery. And so I worked at Amwell, which is a telehealth platform, and led a team that built a patient-facing chatbot to help monitor patient outcomes in between medical appointments. And now I kind of want to bridge those 2 things together and tackle one of the more pressing issues in the US today, which is postpartum depression. So 1 in 5 new moms in the US suffer from maternal mental health disorders like postpartum depression. And unfortunately, 85% of those women are undiagnosed and untreated. And even those who are diagnosed often end up on months-long waiting lists because of the shortage of mental health clinicians. And so when I arrived at Sloan, I was lucky enough to meet the founders of Nurture. They're here today, and they are trying to tackle this exact issue. First, they've already created a prediction algorithm which uses machine learning to identify pregnant women who are most at risk of suffering from postpartum depression using demographic information and past medical history. And as part of the MAD Fellowship, I'm really excited to work on the prevention piece, which will be designing a self-guided therapy chatbot to empower those women to improve their mental health outcomes before symptoms even arise. So the idea is to have kind of this educational chatbot be a digital companion for women throughout their pregnancy. We would enroll high-risk women right around the end of their second trimester, and it would be with them throughout the rest of their pregnancy and even after birth. The idea is for the chatbot to be mobile-based and deliver bite-sized educational modules every day that help empower women to develop the skills needed to manage symptoms if they arise and proactively identify a support system. And this is based on a clinically validated protocol based on CBT, cognitive behavioral therapy. And I'm really excited to be able to research and test and hopefully deploy this tool in collaboration with 4 OBGYN clinics in the South Shore, and be able to interview mothers, women, clinicians to better understand their needs and test our prototype. And just to end on a couple more questions, because I think questions are really central to design. And throughout my project, I want to focus on understanding more about conversation design and gamification. So first, what tones, length, and frequency of chatbot messages might ensure easy digestion of the educational content? And then how might gamification techniques actually encourage the repeated and sustained interactions with the chatbot while still remaining really sensitive to the personal and serious nature of postpartum depression? So excited to dive into these questions and surely many more throughout my project. Thank you.
Hello, I'm Alexandra Rieger, and I'm part of the 2023 cohort. And so wonderful to be with the prior cohort and also the new cohort, and thank you all for being here. I'm a doctoral candidate in the MIT Media Lab in Todd Mackover's Opera of the Future group, and I am an interdisciplinary designer and mechatronic engineer, a cognitive neuroscientist by training, and a multi-instrumentalist musician. And my unique background and experiences converge to allow me to create unique designs and technologies to support patient healthcare from really anywhere in the world. And I'd like to start out today by posing a quick question, which is, how many senses do we have? So let's hold up some hands and let's see. There's some, I'm seeing all different types of answers. I'm seeing 5 senses coming up a lot. And so I see 6, someone might have a 6th sense there. We've got over 100. And in my research, I've been able to understand and explore and leverage these senses beyond the 5 to support patient healthcare. Just a few fun senses that maybe we don't always think about. If you know whether you're hot or cold right now, that's your thermoception. If you know that maybe I'm running a little long with my time, that's your chronoception. And if you know where your hands are in space without looking down at them, that's your proprioception. The human senses are a high sensitivity indicator of health status and how we're doing. As we've known a lot recently in the last few years, especially, changes in olfaction and taste can also indicate biological or neurological disease, but also differences in hearing can also reveal health and cognitive status. So by targeting the senses, researchers and designers and providers can also positively impact health. And that's because our senses are a bidirectional interface. So by measuring them, we can understand about health, but by also targeting them, we can promote health. And so this is where my work and my project comes in, and I design different omnisensory MediMusical devices to help rehabilitate different brain regions. I'm involved in a MIT MGH clinical study with stroke patients. Unfortunately, strokes are becoming even more common with some of the uptake of different viruses over the past couple of years. And right now, a lot of the patients are going home with tennis balls and squeeze balls. And I thought we could do better than that. And so it's been wonderful working over there with the clinical team and Dr. Ming Ning Ning, just to find better solutions for patients. And really innovating for efficacy and access and equity. So thank you so much.
Hello. Hello, everyone. I am Mariama N'Diaye. I am the first cohort of this incredible organization and being a MAD fellow. And so it's remarkable to see the generations that have passed. And so I want to start with why I do what I do. So what you can see here is a campaign that I ran in Lima, Peru during the height of COVID-19 2021. We're working to address the growth of domestic violence cases that were occurring and figuring out how can we do this within communities and centering those who were experiencing, but also the comunitarias, I forget how we call them. Defensoras comunitarias were actually a cohort of incredible women who were leading this work on the ground. And our effort on my end was to be able to support and uplift this. This image is me in the kitchen in the back of a community hall in Houston, Texas. We're working to reduce the amount of kids that were being arrested on school campuses with the Houston Independent School District. And this was the first time that they had seen this kind of prototyping really quickly of, after we leave this session, how do we as a team figure out what our working groups would be? And we then spent another year creating equity audits across the entire city. So you're probably wondering why I'm doing this in the first place. I was at Bloomberg Associates as a program manager on the social services team, where I discovered the IDEO.org Human Centered Design Toolkit, which I'm sure you all have, and have since then been dedicated to supporting this. So while I'm here at MIT as Morningside Academy for Design Fellow, I partnered with MIT GovLab. You'll see this is the only photo I have that showcases a case study that we wrote. It was an intergovernmental innovation for the federal government in Sierra Leone that was working on building an innovation lab. And what were the actual challenges for them to do this? So they took a human-centered design methodology, tried to apply it, and it was really freaking hard. I think we need to talk a lot more about those challenges of how do we take frameworks that have been applied in one setting, but also make them more modular and more applicable. And so here I am today defending my thesis just this morning around the need for a more systems-carrying design on how we support those who are applying design in the public sector and inviting a lot more care and depth, whether it's within our team, within our communities, and across government employees. And so I look forward to diving into conversation shortly with all of us in our cohort around the conversation around bodies. So thank you.
We'll have a few minutes of group discussion, and then we'll open it to the floor for Q&A.
So I'll kick us off. We had a session before this where we kind of got to learn about each other, and a theme came up around how do we tackle challenges that are happening in society from a much more upstream approach. And so I'm curious for you, Clemence or Alexandra, what does it mean to take things upstream within your work?
Sure, I'll kick us off. So I've been working in public health for all of my career, and in public health, prevention is always seen as, in most cases, more effective than treatment. And so I think that's really key to the work I'll be doing with Nurture next year is trying to figure out preventative approaches, not just how do we treat postpartum depression, but how do we prevent it from actually happening in the first place? Because we see that most women get diagnosed usually at their 6-week postpartum appointment, but almost 40% of women actually miss that appointment. So women are falling through the cracks, and then those who are diagnosed often have symptoms that are difficult to treat at that point. Depression is associated with avoidance, and isolation. And so how do we actually get ahead of that and empower women to change how they, perceive pregnancy and motherhood before it's too late?
Great. Thank you so much for sharing. That's so important. I'm also in the health space, and so thinking about similar sorts of things. Also in terms of patient compliance and what are the things that people can do now that's really going to make a big difference for them further down the line. For some of the stroke patients that we are working with and designing things for, about a year after having a stroke, that's the most important time to really, make the biggest difference. But it's almost like, not everyone has access to the very top physical therapy and, recuperative therapies that they would need to have. And so what are those things that they can do from home? And it's almost like when you have piano lessons, you may not want to practice every day, but you have to, and restoring that agency. But then there's also the sign where it's upstream and thinking about how can the senses support diagnostics and, understanding that our senses are really a great barometer of human health. Before we have further Alzheimer's symptoms, people start seeing less of the color blue, for example. Olfaction changes. People, who have other sorts of symptoms of dementia prior to seeing any of those things, we can see it in the senses. They can't smell peanut butter as well. And so there's all of these kinds of things that if we can start developing the tools for doctors and clinicians to pay attention to these changes, we can help to get support for patients a lot faster.
So interesting, because I am not in the health space, but I do focus a lot on the social determinants of health, and a lot of that is spatial. And so how are people's environments, whether it's stress or fear or high rates of asthma or, for example, Cancer Alley in New Orleans, Louisiana. And so all of these spaces that come down to the body in terms of the way that people walk through and live in these spaces. I think for me, I utilize design as a way to, as early as possible, work to imagine kind of new worlds, using design as a tool set to do that, as opposed to very much so retroactively trying to constantly band-aid the issues. And so it's interesting, I feel like from both of you, it's this sense of how do we address the root causes of challenges and utilize what is out there that hasn't been utilized to imagine new futures. And I'm taking it from a more societal scale level, but still on the individual perspective.
That's wonderful. It occurs to me how all of our work is with humans and the human body, but all in different capacities and different angles. But another thing that we found we all really share in common is also an approach to equity and really creating designs and solutions and collaborating with communities to really shift the balances so that everyone has that much needed opportunity to attain, whether it's rights or healthcare or access. What does that mean for either of you and both of you in your work?
Hello. Okay, great. Equity is at the core of the reason why I think that design makes sense in government in the first place. The reason why I say that is I grew up in Harlem, New York, in a building that now still has an F rating, even though it's been 30 years, and nothing has changed. And having grown up in that space and then still be in government arenas where conversations are still being had on, well, who do we talk to? How do we reach them? Who do we engage? And discussions and decisions are still being made in city halls that are not relevant to those who are actually the ones experiencing it. I think equity is at the forefront of why I think we need to be addressing, where I went to a thesis defense just earlier today where it's like, I just want to make sure that everyone is okay, period. That not that a select certain amount of people are thriving and that the rest are actually dying or suffering in order for that to happen. And how do we ensure that there's a baseline and using government as a responsible entity to ensure that everyone on this baseline is okay. on an individual basis. And you have to take an equity lens to do that, given the systemic racism of this country and how everyone's starting on very, very different playing fields, and utilizing design as a way to kind of work to equate and help to alleviate those challenges. So that's the angle that I'm coming in, but I'm curious for you.
Wonderful. Yeah, definitely resonate with that. I think working in maternal health is also just rooted in equity, gender equity, also racial equity. Women of color suffer from postpartum depression at higher rates than white women, partially because they experience higher rates of childbirth-related trauma, which is a high risk factor for depression. And unfortunately, we're seeing that those same women are also seeking mental health treatment at lower rates. And so that disparity there is something that we're trying to address through this tool. And I think that's why I'm really drawn to digital health, is because in today's day and age, digital tools can really expand access, especially, over 90% of people have smartphones now. And so having, help in our pockets and being able to really easily have access to women who need the help is really central to our work. So yeah, I think it's a really important piece of our work in design. Yeah.
That's great. In my work, I also, have a lot of understanding of, the different disparities, especially for individuals and populations who have been marginalized by the medical care industry. And, a big part of it is that I work in telehealth as well, and understanding how my devices and these instruments can allow people, whether they're in rural areas, whether they don't normally have access, that they can get, the best care possible and available, no matter where they're tuning in from, and that we can also have more of a global perspective to medical care. And so a lot of these sensored instruments are able to standardize and add numerical data and values to things that don't currently have any form of standardization. And so this is going to allow our world to collaborate on this medical and design basis more so than, we've been able to previously, and more effectively, because we've seen during the pandemic that it can happen. And that's something that I see for the future, and also making a difference in the lives of people that most need it.
It looks like we might have a couple minutes for audience questions, if we'd like to open it up.
Thank you. To Clemence, first of all, I really appreciate the work you're doing. PPD is something that's affected people in my family, and it's a horrible thing, and the more work to combat it, the better. That being said, I just want to confirm that you're doing everything possible in terms of data privacy and security, especially given how legislation is going in this country that's hostile towards women and their bodies. So just wanted to check that.
Yeah, definitely. That's really central to our work. And while I'll be focusing on the design aspect of the tool, our nurture as an organization is working toward meeting all the compliance standards for data privacy, because obviously that's really, really important in healthcare. So while we're using the data to, find the women who are at high risk, we also want to be really careful about protecting their data. So yeah, thank you for bringing that up.
Thank you all. I'm wondering if you guys have any takes on the treatment prevalence paradox, where more people are being treated for depression than ever, but it's also true that rates of depression are increasing faster than they ever have before. And if that also applies to postpartum depression. Thanks.
Yeah. Sorry, so you're saying rates, can you just restate their question? Thank you.
Yeah, definitely. Okay, so more people are being treated for depression than ever, and also rates of depression are rising faster than ever. So wouldn't it be true that if treatment was increasing, rates would go down, or the prevalence of depression would go down? And does that also apply for postpartum depression? Thank you.
Yeah, great question. Thank you for repeating. I think part of it is also that just depression and mental health is luckily being destigmatized. And so I wonder if we're just seeing more people come forward with their symptoms and seeking help. And so that's contributing to the increase of depression, even though we're also seeing more treatment for depression. So I think that's a great thing. And I think that's really central to our work, is like bringing that forward and making sure that we can normalize depression, because it's something that the more we talk about, a lot of mental health is kind of breeds in secrecy, and thrives on secrecy and hiding and isolation. And so the more we can talk about it, I think the better we can treat it.
Alexandra, you had mentioned that people who've had strokes go home with a squeeze ball and not much more. Can you tell us a little bit more about the things that you're developing that people could use to rehabilitate themselves?
Absolutely. Thanks for the question. We are in the process of developing highly censored instruments that also harness the senses so that they can access really more brain regions and engage those really as a way to bridge over the regions of the brain that are not doing so well or have been damaged. And so really targeting that information pathway in the brain, the frontotemporal regions. One of the best ways to access this whole region at once is also through other kinds of senses. And so incorporating aspects of music and design and motion and movement and kinesthesia is so important because it allows for so much more engagement of these, motor neuron regions, as well as some of these other areas in the brain. And one thing I've always said, some of these devices allow patients to reach for an auditory goal instead of just an arbitrary goal. And what's very exciting is that they also are filled with sensors, and so that doctors can tell exactly how a patient is doing. Telehealth is now stabilized at 38 times higher than before the pandemic, and so this is a part of the new normal. But how can we really harness it so that it is helpful, especially with patients, one can overestimate or underestimate how one is doing, and it's difficult to know, especially when someone might be dealing with hemiplegia or loss of feeling. And so that the patient is getting the biofeedback through this instrument, but also that the doctors are getting the information they need to really support the patient to make everyone's job a little lighter. Yeah.
Great. Thank you so much for your questions. Thank you both for this conversation. And I think we'll hand it off to the next panel. Yeah.
Excellent. Thanks so much. And so for our second panel, we will be moving to the scale of objects and thinking about material properties, fabrication methods, and assemblage, and how that can unfold new design possibilities. So we will have one MAD design fellow from each of our three cohorts, and we'll hear from Lyle Regenwetter from mechanical engineering, Liane Makatura from electrical engineering, computer science, and Ganit Goldstein from Department of Architecture. So over to you, Lyle.
All right. Hello, everybody. Thanks for being here. The three of us actually have kind of discovered that we have a shared interest for computational design, so that's going to be a bit of a theme throughout the presentations and the discussion. I'm going to start off talking about generative AI in design, and then Liane and Ganit will be talking about computational metamaterial design and textile design. So yeah, let's get started. Because Gen AI is so popular these days, I wanted to do a quick audience poll and ask people, who has tried using some kind of Gen AI tool for a design-related task? All right, about half of the people. So I'm guessing a lot of you have had some kind of mixed feelings about it, right? So on the one hand, Gen AI tools are really excellent for conceptual design. This is a tool that's kind of borrowed from my lab mates. They're working on this, which basically goes from a design sketch and a text description and quickly generates a 3D model and a physical prototype. So Gen AI tools are really good for rapid conceptual design. I mean, this is able to go from a sketch to a physical prototype in minutes, which I think is really cool. So 2 thumbs up for Gen AI for conceptual design. It works really great. There's a lot of potential there. Now, the issue is that Gen AI tools don't do so well with detailed design or very specific design requirements. And to show this, I ran a little experiment here. So I asked GPT-4 to design a truss structure with 20 non-overlapping links. And this is what it comes up with. And I think if there are any structural engineers in the room, they know exactly what's going to happen here. But this truss falls down under its own weight. So, I mean, in a sense, it's kind of violated an implicit design requirement that we have, which is that the truss should really support its own weight and probably a lot more. But if anybody's paying really close attention, they may have actually noticed that this truss violates one of our explicit design requirements as well, in that there are actually 21 links. There's not 20. So GPT-4, clearly fails to, satisfy both explicit and implicit design requirements. And this is a really big problem for detailed design. So I believe, I should also mention that, for all other types of Gen AI models in design, not just language models, we see the same behavior. So this issue with design requirements is really universal. So I believe that to actually get generative AI models to be valid or practical for detailed design, we have to think about ways to incorporate design requirements into the actual training process for Gen AI models. So you might ask, how are Gen AI models currently trained? Well, usually they just look at a bunch of examples, and then they generate things that look kind of like those examples, right? It's pretty simple. In design, this means that they're going to study, our favorite designs. We'll show them our favorite designs, and we basically say, do that, generate things that look like those designs, and it'll try its best to generate things that look like those designs. Now, the problem is that these Gen AI models are never exposed to examples of designs that violate constraints. So, most of us would have a hard time, following some rules if we never saw an example of somebody breaking that rule. It's kind of like learning from your mistakes, right? I think we all understand this intuitively. So I think the solution to this is that we need to show Gen AI models examples of designs that violate those constraints. And by training Gen AI models in this way, we can actually teach them to understand those constraints. This is something I've experimented with a lot, and we do see, in fact, that Gen AI models that see examples of constraint-violating designs are much better able to satisfy design requirements, and in addition are a lot more data efficient. I wanted to highlight one more thing here, which is that thinking about design representation is also very important. This is kind of the lens by which Gen AI models see and understand designs, and by improving design representations, we can also improve the ability of Gen AI models to meet design requirements as well. I won't go into a ton of detail on that because I think Liane will be talking a little bit about design representation, so I'll just use this as the cue to hand things over to her.
Great, thanks so much, Lyle. So my name is Liane, and I'm a PhD student in computer science. And I work primarily on designing these small-scale geometric patterns that can actually induce interesting mechanical behaviors in 3D printed objects. And so what you're seeing here is a series of blocks that have been printed by the same 3D printer on the same run with the same material. But they, because of the patterns that we've chosen to fill each volume with, they respond in very different ways when you sort of poke them with a pen, in this case. I'm going to have the sample with me if anyone wants to play with it at some point. But these patterns that we've chosen to fill the volumes with are known as metamaterials. And you've already seen how these two examples can induce different deformation behaviors, but that's only the tip of the iceberg here. So we can also choose to design structures that are incredibly lightweight but still preserve their strength. And if we consider different types of geometries, we can also come up with structures like these, which look a bit crazy, but they actually have the ability to block sound waves in certain frequency ranges. So you could use it for soundproofing or any number of other things. So even from these three properties, which again are really just scratching the surface, we can already see lots of applications for these sorts of structures in everything from aerospace to biomedical engineering. And so there's a huge push right now to understand the opportunities here, but that's incredibly difficult to do because there are so many different shapes we want to consider, and it's actually not clear which variations are going to lead to the properties that we care about. And moreover, it's actually not even clear how to characterize the design space we're trying to move around in, because there are, again, so many shapes we want to be able to explore, and they're all characteristically different. So some of them have sort of these thin beams, some of them are these sort of sweeping shell structures, and it's hard to capture them in a unified way. And each structure itself is also incredibly complicated, so it seems like we're doomed to use some very high dimensional and inconvenient sort of representation in order to capture them all. And so a lot of my PhD has been working on wrangling this really unruly space and trying to impose some structure that lets us represent structures like the one on the top in a very compact way using the graph nodes that you see on the bottom. And just by simply recomposing these nodes, we can actually represent tons of different types of objects for the purpose of exploration. And once we have this representation, like Lyle mentioned, it becomes a lot easier to actually kind of traverse the space that we care about and look for interesting designs. And so in this example, we've embedded our representation within a human-in-the-loop interface, so you can build up and evaluate structures using the sort of integrated prediction tools. We can also imagine doing something more akin to what Lyle was showing with generative design tools, where you train on this representation and then allow a model to sort of give you suggestions that span the gamut of spaces. So here we didn't really impose a lot of constraints and we let it run wild. And as you can see, it came up with some pretty wonky structures that people might not have thought of. But because the representation is designed to be intuitive, it's also really easy to direct it in a certain region in order to get variations like these, which of course are still very diverse, but they share a common design thread as intended. And so there's, now that we can explore these shapes, it's much easier to understand not just how a single metamaterial will behave or impact its object, but kind of to start understanding the scope of possibilities and limitations here. One of the things that is most critical is really making sure that the things we are promising and predicting in our digital space are going to actually persist once we bring these objects into the real world. And that's something that I believe Ganit will be talking about more in her talk. And so I will hand it over to her. Thanks so much.
Thank you. It's been a pleasure to work with you and kind of think about the computational design world and how we are kind of really integrating lots of our work together. My name is Ganit Goldstein. I'm working on computational textile design, and I graduated from the Master of Science in Architecture from the Computational Design Group. I worked with Skylar Tibbetts in the Self-Assembly Lab. And it's a pleasure to kind of share with you many works that I've been working on for the last few years about textile design and kind of designing new relationship between past and future textile technologies. And I believe that textiles serve as a medium that connects stories between world perspectives and cultures. The projects that I will show today weave together past and future technologies for designing new relationship between the hand and the machine. And I'm looking at textile as a medium to combine those relationships with computational design, sustainable manufacturing, and embedding sensors into advanced textiles for extreme environment. Such as the example in the left that I will explain a bit, but it was a collaboration between many researchers across MIT to develop the new generation of spacesuit design using advanced fiber and sensing technologies. And in fact, the ways that we can produce very complex fabric constructions and garment is intertwined with the connection between coding and textiles. The Jacquard loom is a machine that wove complex patterns using punch cards for instructions, marking it as the early form of computers. Although the machinery for producing fabrics is very complex, the fabrics are still very much static. So my research investigates the potential for textiles. So investigate the potential for embedding new functions into textiles. and accessories and garments. In my work, I'm interested in exploring embedding interactions such as self-forming fibers, growing natural colors into textiles, building interactive elements into the fabric, and connecting sound, color changing, and into the accessories of the design, and really designing interactive component in the physical and the digital format to build platforms that create new languages for design through interaction between garments and our environment. And these are a few examples of garments that connects weaving technique with 3D printing technology, combining all the new techniques for hybrid textiles. So up there, it's a documentation from my time in Japan that I learned ikat weaving, and then I combine it with 3D printing technology, but really kind of working on the layering process of how I can work with a 3D printer to produce those garments. This is an example of creating new fabrics using multi-material 3D printing. And it's very complex process because those pieces are assembled as there are around 24 panels that are all computationally designed without any sewing. So the idea is to really think about the labor-intensive process inside garment manufacturing and how we can eliminate that by computational workflows. So one of the things I've been developing through the time is designing for customization. So how do you make garments that are fit to measure to specific form of the body, and what does it mean to have garments that are fit to measure for a specific person? And those customization of garments are actually allowing opportunities to design new materials and new form that needed specific kind of properties inside the fabric themselves. So this is an example of a full garment that is produced from recycled filaments and recycled water bottle fabric. And here I tried to kind of think about the next cycle of the materials and how we can reproduce textiles from recycled material. And the last thing that I will mention is probably the present and the future of my work. This is a 3D knit spacesuit sleeve that I worked with multiple labs and collaborators across MIT, and we developed a sensing sleeves that can be kind of the future of way to produce customized garments for space application, and really embedding sensing technologies of fibers into the textile structure. So we use 3D knitting technology, 3D scanning, and fibers that can sense individual pressure on the skin, and really thinking about the future of sensing our body to in advanced environment. Thank you so much.
Okay, so to kick off our little panel discussion, I thought I'd ask a question for all of us, really, because we're all interested in some form of computational design, which is ask, why bother with computational design? What are the benefits of using computing in design, and what do we really hope to get out of that broadly?
Yeah, I can start by just saying that it's actually a way to make crafts for me. So I always use 3D printing and modeling just to open a creative kind of workflow and experiment with different materials, and then kind of a way to go back to reality. So lots of my work is really reverse engineering kind of objects, produce them, testing them, and then, making the next generation of prototyping. So I think as a prototype kind of methodologies of trial and error, those kind of computational workflow are really important.
Yeah, I definitely resonate with this idea of prototyping. Computation allows us to look at so many more opportunities than we would be able to in sort of a traditional, find someone to fabricate it, test it, realize you were wrong, and then go back to the beginning. And this kind of reminds me of what Mariama and the first panel were talking about with this idea of not putting a Band-Aid on something after you've gone through the whole design process, but really trying to have the important things up front.
Yeah, I think to stress a very tangible benefit that all of us can hope to get out of computational tools is that, at the moment, the economics of design is that, most people design products to reach many, many different people. So this means that most of the designs that we have in our world are not really customized to our specific needs. And I think with computational design, we can hope to increase the throughput of design so that maybe one day we'll all be able to have customized products exactly built for our particular needs. So, maybe a bike that is fit exactly for my ergonomic needs, or for example, clothing that is exactly perfect for, your body type. I think one other thing that I'll quickly mention is this idea of design democratization, which is that ideally with computational tools or AI tools, we might be able to lower the barrier of entry to design. And I think, as designers, we often think about empathizing with the user, and there's nobody who can empathize better with the user than the user themselves. And if we can empower the user to use computational tools or AI tools to design their own products, then they're going to do a better job than anybody else could. Yeah.
So one other thing that, because we're all computational designers, we're all obviously pushing this as a way forward, but something that's really important to keep in mind is when are we able to trust what a computational design tool spits out for us, and when is it important to kind of be skeptical or verify that information?
Yeah, I think that's a really important question, and especially for Gen AI models, which is what I'm working with, it's really difficult to trust what comes out of them. And I think the reason for that is because they are probabilistic models, which means that any possible output you can think of for a generative model, no matter how improbable it is, there is still a finite probability attached to that. So anything it could possibly come up with, there's a chance it'll do that. And if we're designing something in a safety critical application, we obviously don't want to roll the dice with small probabilities when people's lives are at stake. So it's very important to kind of verify what computational tools spit out in a lot of cases, especially with Gen AI models.
Yeah, I think I really connect to your kind of example of the spongy elements, because I think you kind of emphasize what's the properties that we need to each fabrication methodology. So if you use the same material and you can test it and fabricate it and really kind of compare, I think that's where things are much more moving from the digital to the physical and vice versa. So I think that's kind of a simulation tool. So it's not the aim to design through the computational workflow, but it's kind of the aim to fabricate those elements and see what's happening and kind of bring this information back to the computational workflow.
Yeah, I completely agree. So even though a lot of, this resonates with me, because even though a lot of my design is not really based on these unpredictable AIs, it's very well established things like finite element method. There are still some things that we don't really fully understand how to simulate, like, what will the material properties actually be when you get it out of a 3D printer, and have we respected that? And so it's, yeah, even in sort of established things, it seems really important to always double check and see what reality tells you is how you're doing. So I think at this point, we'd like to throw it to the audience for questions. Is there any?
I guess we explained things really well.
Here we go.
Everyone's lost.
Hi, thank you. Lyle, I'm curious, when you have generative AI models that can successfully build some of these designs, what you see as the role of experienced architects filling in there and how they provide their expertise.
Yeah, I think that's a really good point. And I think we're very far away from the point where Gen AI models can do the entire design process. So I think a very tangible first step is this idea of human AI collaboration, where you have design tools that can automate certain tedious aspects of the design process. And then you have experienced designers who are familiar with the nature of their particular problems, who can verify what the AI does and leverage them to accelerate their workflow. So I see this idea of human AI collaboration as really the first step towards accelerating the design process for everyone. And I think that's a very tangible benefit to Gen AI that a lot of experienced designers and practitioners can hope to get out of it, if that makes sense.
Hi, my question is for Liane. I'm not sure if I'm pronouncing your name correctly. You're producing 3D printable materials with exceptional properties. So I was curious, do you define the properties before and then you explore what structures would support that? Or do you explore with structure and then decide what function could this serve?
Yeah, that's an excellent question. The answer is that it's useful to do both. And so I tend towards kind of examining the shape space first. So just designing the structures and seeing what comes out. Because I think that process of exploration is really fun and reveals things that we might not have thought to look for. And so that's my personal take. But it is also, I'm always designing things that can be used in a more targeted search, like you're alluding to. So where we say, this is what I'm designing, these are the requirements that it has, and this is what I would need my material to do, and then kind of work backwards in order to find the structure that provides those functionalities. They're both super interesting ways to go about it. There's a lot of work in both directions.
Well, we have time for one more question. Anybody?
There's one at the top.
I have a question for Ganit. I'm curious if you have any hint on the next potential GPT for textile design. Let's say you want to have something specific. What are you worried about if that comes? And what are you excited about if that comes?
Yeah, it's actually a really good question. And I think the first thing that comes to my mind is actually designing new properties of materials. So it's almost connected to Liane works that you can, and my work in multi-materials 3D printing. So you can actually design each pixel material properties inside the fabrication. So now it's much harder to control. It's much more in the fiber level of 3D printing. But if we can think about a voxel or kind of pixelizing material properties, we can think about how we are embedding new functions in each pixel of fabric. And that's, I think, the future of kind of this AI modeling, that you can fabricate lots of materials in one print, or kind of multiple functions that are constructed through the layer of the fabric. So one of the things I'm working on now is kind of thinking about fabrics that have multi-dimensional properties, so you can embed electronics inside each area and kind of fabricate where do you need what. And I think AI will be the perfect tool for that, for the future of multi-material kind of properties design.
Okay, thank you so much to our second panel. And for our final panel of today, our third group will explore design of environments at larger scales, community scales, ecological scales, and we'll be joined by Elijah Martin, a fellow from our first year from Civil and Environmental Engineering, James Brice, who's from Architecture, and Woods Hole and Environmental Engineering, and Dení López, who's from Urban Studies and Planning. So over to you, Elijah.
So I'll be talking about designing plastics for degradation. So I'm sure, as many of you are aware, plastic waste is a tremendous problem. Pictured here is a bunch of plastic waste in a water body. And we know very little about the environmental lifetime of most of this plastic waste. And if you're still not convinced, the problem is growing, and it is also detrimental to our ecological systems. So plastic mismanagement is predicted to increase as well. And so if we start by thinking about a plastic's life cycle from the design of the material and object through the production, the use phase, and then the various end-of-life options, We have ideally recycling, where it will get put back into production. The next best thing would be disposal in a proper waste stream. And then unfortunately, we end up with a large term of mismanaged waste. And so a solution for this is designing for degradation, where typically we've been feeding the use phase back into the design process, how the material interacts with the user and also its material properties. Recycling has fed back into the design as well recently, but we'd really like to move this mismanagement term to being sort of this rapid feedback into the design process. And in order to do that, instead of waiting for the plastic to move through its whole lifetime, we would like to have this mismanagement be a rapidly iteratable variable that we're able to tune and have it feed back into the design process. Specifically, we think the best way to do this is to do it on timescales that are relevant to industrial plastic production and new material design. So we plan to do this in a high throughput way, and specifically, there are many types of degradation. What I'll be focusing on is elucidating data for photodegradation, just because it's been shown to be an important initiator. So currently, we have these really large format solar simulators, and we'd like to actually scale this down quite a bit, taking inspiration from biology to this 96 well plate format. If we blow this up, we can see that it's orders of magnitude smaller across multiple dimensions. So getting into the design of our device, we, starting with our proof of concept, we'll check off some of our design requirements as we go through our final photoreactor module that we then put together in this 72 sample assembly. And so this is the fabricated device, and this is it operating. We run these experiments in water with light. And so this little graphic is just showing kind of basically what's happening in each sample. We have different types of plastics in water. We irradiate it with light, and then we measure the amount of plastic that has broken down. And so we've confirmed degradation for a bunch of different commodity plastics. So this device is really aimed to be used both to gain more information about plastics that already exist, but also to rapidly test new materials as they're made. And so we see also great agreement between our current device that we've designed and previous methods. So the most important thing with this new high throughput device is that we're able to get data that is meaningful and relevant to the environment. And so looking forward, we have demonstrated the high throughput capability. We've showed agreement with previous literature. And then the really interesting thing that I actually didn't talk about much here is that when we're doing it in the small format with UV LEDs, we're able to tease apart some of the mechanistic degradation processes that are happening. And so that is some of the work that we've done going forward. And then if we look back to our sort of new design cycle for materials, I think we're a little step closer to this high throughput photodegradation and material design. So thanks. Hand it over to James.
Hello there. My name is James Vincent Brice. I'm a graduate student in the Department of Architecture and the Department of Civil and Environmental Engineering with this year's cohort, outgoing. So I work in the area of nature-based coastal adaptation. For anyone who's not familiar, coastal adaptation is basically, the rapid urbanization of our coast, and climate change has driven a lot of kind of hard infrastructure stabilization projects all along coasts all over the world. It's a problem that's not going away. We have sea level rise, we have increased storm severity, erosion. These structures work. I mean, we've been doing this for 100 years now, but there's a lot of negative externalities that are associated with big seawalls and bulkheads and groins. They restrict access to the ocean for coastal communities, both human and non-human. They completely destroy intertidal regimes. They usually have brittle failure modes. And in the case of climate change, when we don't really know how much our sea level is going to rise, the question becomes, how tall do you build the wall? So a potential alternative to this is what is called nature-based coastal adaptation. So this is the idea that we can embed some of the inherent physical resilience that we find in our mangroves, our salt marshes, and our oyster reefs into the design of our built physical infrastructure. Now, I work specifically with oysters. I could talk about them for like an hour, but the 30-second version is that oysters are amazing ecosystem engineers that have an extraordinary ability to alter their local environment. They function as critical ecological infrastructure by increasing biodiversity and providing habitat for countless marine organisms, the benefits of which propagate up the trophic web, so then we see stronger fisheries of commercially valuable fish. They also filter like an insane amount of water, and so they play an important role in local nitrogen cycles. They also improve water clarity so that more sunlight can get down to the bottom, and your submerged aquatic vegetation that needs sun is happy and produces lots of oxygen, so really important. They also function as social infrastructure by acting as a substrate for increased environmental stewardship within coastal communities. There's evidence dating back like 8,000 years that oysters have played a large role in coastal landscapes. We find these like shell mounds that are evidence of sophisticated mortuary rites with the oyster. So there's a lot of work now that oyster restoration practitioners are kind of increasingly trying to build green jobs in coastal communities through education and outreach. And of course, the oyster also is, mariculture is a very important industry. But then for me as a physicist by training, what I get really excited about is the physical infrastructure that oysters can really function as. So by acting as this like rough thing in the submerged surf zone, mean flows like currents or waves that propagate over the oyster reef lose energy to turbulence. And so why that's important is the calm waters in the lee of the oyster can reduce erosion on our salt marshes. It can stabilize our shorelines, just like those big bulkheads. It can even reduce wave-driven overtopping and coastal flooding at large scales. And the crazy thing is that these are living things, so they grow with time. And we actually have evidence that the accretion rate of the oyster reef can keep pace with sea level rise. A lot of my interests in general have to do with this idea of what building with nature is. When we're talking about nature-based solutions, like what does that even mean? We tend to know now that it's not this. You can't just put plants on a wall and call that building with nature. What is less talked about, though, is what is happening in nature-based coastal adaptation, a kind of similar thing where we've got a lot of engineers who are like, okay, great, oysters do this thing. Let's just like plop them on some concrete. But it's actually a lot more complicated because the oysters don't really like that. So my work has to do with starting from the biological consideration. What are the environmental conditions that promote long-term oyster reef success? And how can we use that information to then optimize wave energy loss in that order? So I work in an environmental fluid mechanics lab, and I study mechanisms of wave energy loss in constructed oyster reefs so that we can kind of optimize this design solution. And finally, I mean, we're nature, right? We're a part of the environment. So for me, building with nature is also engaging with coastal communities, doing outreach and education. There's a group in New York, the Billion Oyster Project, that likes to say restoration without education is temporary. So I definitely take that to heart. Ultimately, building with nature is sort of the sum total of reconciling the physical, ecological, and social processes in these landscapes. So this is the work that I do. Thank you.
Hi. Can I take this out of here? Hello. My name is Dení, and I'm gonna get out of the podium because it makes me nervous. I'm from Mexico, and my story really starts in 2017. There was a massive earthquake in Oaxaca, which is here in the south, which is mainly indigenous communities. It was like the strongest earthquake of the century or something like that, they called it. But 2 weeks later, there was an earthquake in Mexico City, and all of the attention shifted to Mexico City. That was a huge problem for the communities here. For example, these is all of the plan that existed for rubble management, all of it, 3 pages for Oaxaca. And essentially it said, do what Mexico City did, create a park with all the rubble that you missed. I don't know, it was like nonsensical, to be fair. And what actually happened on the ground with rubble was this. Massive misuse of resources, no one knew what to do, an ecological crisis of its own. So when you go to Oaxaca and you ask people, hey, what happened with the disaster? They actually answer, what disaster? The earthquake or what the government did after? So this is where I was like, okay, I'm an architect, I'm an urban designer, I'm an academic, I'm a researcher. I can do something. We can do something about this. We cannot just be here and stay stable. So we created a participatory action research organization called Bichechedilla, which in Zapotec means, well, in Spanish, it's Zapotec in Spanish, it means spread the word. And it's what we wanted to do. Connect people on the ground to people here, to policymakers, to start and do something for real. So we partnered with students there in Oaxaca and then expanded the team. 2 people across MIT and Harvard and Oaxaca and UNAM. So this ended up being like a huge collective of people that's still working today on not only understanding what happens during a disaster, but also doing things while we understand to not just stay on paper. So as a designer, for me, this meant a specific method. What can I do? I can do archival research for sure. I'm good at photography. It's going to work out for some reason. We can do some mapping too. Go around, understand what's happening. Let's do workshops with women and children. Tell them, let us understand what the use of public space is, how has it changed after the earthquake, what can we do for you? Let's do a survey, which we partnered with people from public health across the 5 towns that we were working in. Let's do interviews with people here, people there, people everywhere. It's like, we're going to understand this, but also we're going to do stuff about it. So what did we do? First, there's a website. All of the information we collected is public because people on the ground asked us for it. There are many outcomes. We did an exhibition. This is my wife on the back of a truck because we went to each of the towns that we worked on after we worked on them to say, here are our results. This is what we learned. How is it useful for you? How is it useful for us? How do we share this information? We also designed projects as architects, of course, with reusing the rubble from the earthquake to create community centers. This is a project from one of our partners, which treat water, et cetera, et cetera. I wrote my thesis about this back in my master's. And on my thesis, I asked people, like, who's responsible to manage things after a disaster? And they were like, the government. And I was like, yeah, of course. Do you trust the government? Everything on your red is who people don't trust. And it's government, like municipal government, state government, federal government. Who do you trust? On the left is a church, but the second one is universities. And I was like, okay, if you're gonna trust universities and we can do something about it, I'm gonna keep going. And that's what brought me here to MIT. And one of the things that I'll tell you very quickly about that I'm working on right now is after the earthquake, of course, COVID started when I started the PhD. And I started to understand the patterns of mortality and what is going to happen in indigenous communities. And I was also taking a photography class. So again, I was like, designer cap. I met Doña Laura. And Doña Laura, as a project for my photography class, I interviewed her, understood her story. Turns out she lost her house to the earthquake that I told you about. And while rebuilding it, her husband was rebuilding it. Her husband died of COVID. And I was like, disasters are not a one-time thing, they accumulate. And they accumulate, and that means something, and we can do something about it. So, Doña Laura, I asked her, can I please do my project with you? And she was like, of course. And can we fundraise? Of course. So this is her husband actually here, her story, her family. Get the team together again. This is most of the team. Many of them worked on the first project too. Let's do something about it. Let's build this storefront. Finish your project. And while we finish your project, I'll understand what happened in policy and what failed and what not. But let's build this thing. So we are building it right now. It's one of the things I'm working on. And there's going to be a memorial wall for her husband. That's who I am, and that's what I work on. Thank you so much. We'll move on to the discussion.
Cool. Really great to hear everyone's work from before also, but especially you guys working at the scale of the environment. When we were talking, something like a reoccurring theme that came up was scale. Because when you're working in design in the environment, there's not just like an enormous span of spatial scales that we're dealing with, but there's also these temporal scales, whether you're talking about, the scale that controls chemical, degradation or the scale of disasters. So I would definitely be curious to hear how spatial and temporal scales influence design in your work.
Yeah, I can go first, I guess. I think like the larger scales of both time and then also space are really what motivate the work. And then, of course, in the lab, we have to abstract everything. So we try to bring that into scales relevant to a PhD or to lab work or something like that. So it's also important to like be able to compete at shorter time scales to then change the way materials are designed. But I think if you really lose the North Star of what are the long-term impacts, that's kind of how we end up in the place we've ended up.
To me, time and scale are everything in a disaster, because if I cannot connect them, I cannot work. So during a disaster, I need to understand the mistakes that have happened, the ones that can come, the ones that are like evolving in the present response, and also who's involved. It's like, is it the government? Is it the people? Is it academia? So like it's connect. As a designer, that's my job, to connect and to be able to connect in a way that results in something, if that makes any sense.
Right. There's like a telescoping that I feel like I see happen in all of our work. I think for me, especially thinking about nature and how we define nature, that's always kind of challenging because, I mean, there are the little microphytobenthos that we can't see living in the tidal flats. But there are also kind of like collaborators in any design in the environment. And I think as well, and you can probably relate to, the environment is not just, we learned this in like 5th grade. It's not just the biotic factors. It's like the abiotic factors, right? It's the forces. And those are the forces of people and government, or the force of the sun, or the force of the waves. And so I think for me, like finding the way to focus on the scales that are relevant for a specific problem, but then also always doing that telescoping out is super important.
Yeah, I'm curious, I guess, while we're on the topic of scale, is how you both think about the impact at both the small scale of your work and then also the long term, and how you communicate both of those, potentially cohesive, but potentially maybe sometimes at odds.
Sure. Yeah, that's tricky because especially with climate adaptation, the time horizons for some things are like 50, 100 years. So when you're talking to people about climate change, and you're saying, I promise this is going to be important soon, it's like hard to have that conversation with people. But at the same time, so much of what is driving our need to work in coastal adaptation is what we're seeing right now. It's flooding during high tide. So I think I try to always give people like a near term win or something to focus on. Like, what does building with nature and the environment do for communities now? And a lot of that is improving our relationship to the land and increasing stewardship. And, some of the near term effects like erosion, we can see sediment dynamics pretty quickly, while also having that conversation about, I promise in 50 years, this, oyster reef can be something magnificent. But the work kind of has to start now.
I guess I understand where you're coming from. Like in a disaster, it's easier, quote unquote, because everything that can go wrong is going wrong and you're seeing it happen. So it's like, see how this is happening? This is going to happen again. And people believe you. It's like, okay, of course, an earthquake is going to happen again, etc. So, and all of the things that are going wrong can go wrong again. During the disaster and during the immediate recovery, it's easy to convince people and to communicate that it's important. After, like, give it 6 months or a year, when you want to keep working on it, and now like these things accumulate, it becomes impossible. It's like well, not impossible, but it's like, I promise that this is gonna be important. Pay attention. So, I guess, I don't know. The easiest way to communicate for me is to use a crisis at its most and keep bringing it back and keep reminding people, like, we need to keep this in mind. But it's never, I don't know, it's not black and white. So.
Yeah, I think we'll send it to...
You have time for a couple of questions?
Thank you all for your presentations. They were so insightful. This is a question for James. I really, really enjoy nature-based design.
Thank you.
I learned a while ago that the more biodiverse an ecosystem is, the more resilient it is. And so I'm just wondering what your decision-making process was working with oysters and whether you're looking to expand to co-designing with other organisms in the future.
Yeah, I think part of the difficulty of making nature-based solutions happen is a lot of the way we design is very predictive. So we want these models that have all the answers and can predict this is exactly how the wave is going to transform. And I mean, a lot of my work has to do with improving our predictive models. But at the same time, when you're working with nature and the uncertainty that comes with that, with climate change, but also just, you know, collaborating with an organism that you can't directly communicate with, is switching to an approach that is like adaptive and predictive. And so I like that you brought up that point about resilience, because I think that's why the environment is so resilient, because it can adapt. It's not that it's just like powerful in its own right. And so for me, working with the oyster has a lot to do with not just the capacity of an oyster reef to, you know, attenuate wave energy, but the fact that they grow with time, and that's a process that we can kind of facilitate thinking about things like larval settlement and nutrients in the coastal landscape. Yes, I would love to collaborate with more organisms in the environment, always.
One more.
There's no mic. If there are no other questions, I guess that means you three have solved everything. But please join me in thanking this panel. Well, I hope our program today has given you a sense of how exciting it is for us to be able to support designers across all of MIT, and also how some of the most important work happening right now at MIT in research and universities and in society generally has design at the very heart of how we're approaching the challenges we face. Very complex problems across many scales. And so we're delighted to be able to partner with the MIT Museum, with Boston Design Week. I just have a couple of final announcements and thank yous. First, again, reminder, tomorrow, Design Redefined will be here in the same space at 4 o'clock with Innovators for Purpose. MIT DesignX, our venture-based design program, has their pitch day on May 17th at the Media Lab, so you're all invited to that. We're also excited to host an international conference. The Design Research Society, together with Northeastern, will be here the last week of June. And that's the first time in North America, so that'll bring people from all around the world. And We're honestly so lucky to be able to support our graduate design fellows and how incredible they are, and the fact that we were 100% attendance with this year's 10 new fellows. So please join me in congratulating again the new fellows. And thanking all of you from all 3 of our cohorts. That's 35 graduate students, designers across all different fields we've been able to support. And we're excited to think about 10 years from now, 20 years from now, this wave of designers going out in the world making change. So it's such an honor to be able to get to work with you and support your work. For those of you who are new to MAD, please join our mailing list. You can use the QR code on the screen. And lastly, I just have to thank the whole team at MAD who put this on: Adelaide, Marion, Roy, Jen, everyone, Svava, everyone who got together to make this possible. It's just an honor to work with all of you, Maria, and thank you all for joining. And unfortunately, I have to remind you, the museum closes at 5 o'clock. So enjoy the conversations, but we do have to be out by 5. So thanks again to the museum. Thank you all for being here. Have a great night.